Transmitting data, question 1. The first part of A is just a factual recall question. You must learn your facts. What is the normal range of human hearing? For just 1 mark. Well, it's from around 20 to 20,000 Hertz. You would be given some leeway on these figures. Part 2, what is the base bandwidth of this range? Again for 1 mark. Well, base bandwidth is just the size of the range, or the difference between the upper and lower limits. So in this case it's 20,000 Hertz minus 20, or 19,980 Hertz. Part 3. What would be the minimum sampling rate required to digitize a signal with a base bandwidth of 5 kilohertz? Well, the minimum sampling rate, in order to not lose information, is at least twice the base bandwidth. So in this case we'd need a minimum sampling rate of 10 kilohertz. This is because base bandwidth is simply the bandwidth starting at 0 Hertz, and so effectively gives us our maximum possible frequency. For part B, we have this diagram with a radio transmitter and 2 receivers, and we have to describe the methods by which station 1 could transmit to stations 2 and 3. For each method, state whether it would use short, long, or any wavelength. We're given 5 marks, and so ideally if we can quote 3 methods and the 3 wavelengths, we should pick up the 5 marks. Well, 1 and 2 are within line of sight. So, for line of sight we can use any wavelength. For 1 to 3, they're not in line of sight. We could use ground waves, where the waves of a long wavelength will hug the Earth and go following the curvature of the Earth round to 3. That requires a long wavelength. We could use refraction by the ionosphere. Don't forget this appears as if it's reflection, where the waves would travel up to the ionosphere and come off towards station 3. That requires short wavelength radiation. Or we could use short wavelength radiation to send the signal right up through the ionosphere to a satellite and back. Part C is a question that comes up time and time again, so make sure you know an answer to this. Give 2 advantages of the station sending digital signals rather than analog signals. Well, digital signals can have the noise removed by regenerating. Don't get into the mistake that digital signals don't pick up noise. They do, it's just that it can be removed. We cannot easily remove noise from analog signals. We can also send several signals at once by using multiplexing with digital signals, and they have a smaller bandwidth, so it allows us to fit more channels into a particular bandwidth.